Welcome to Kotlin. This video is part of a series where we're building Minesweeper with Compose multi-platform. Whilst it's designed to be useful on its own, there may be some references to earlier episodes. For this episode we've moved over to Fleet. This is due to the latest version of Android Studio having some issues showing previews for Compose. So to start, we're going to need to see the different tile states for the Minesweeper board. So I have them here. How this is going to work: when we draw each individual tile, we'll have a plain background which is drawn first, and then it can branch off into a revealed state or a hidden. So the hidden is just as you see a Minesweeper board untouched, ready to be clicked. Part of the hidden state, we can have a flag. So all we'll need here is just a boolean of whether it's been flagged. Within revealed, it can either have a number, it can have a mine if the game's over and we can see the mine shown, or it can have nothing at all, and this happens when there are no mines surrounding that tile. So we'll move back over to Fleet, and we need to match that in the code. So we can start by going to the appropriate feature module, which will be play for this, and within the Kotlin code we can add a new file and we'll name it tile state. So within here we'll need a sealed class, and that will be named tile state. If we look back at what it's going to look like, we can see it branches off into revealed and hidden. We'll move back over to Fleet. So the first one we'll do will be hidden. This will be a data class because it needs the boolean to show whether it's been flagged. So we can say hidden, give it a val of flagged, and inherit from tile state. The other thing we need is hidden, and we'll name it revealed. Now this we will inherit from tile state, but within revealed, sorry, this should be a sealed class. We can have whether it's a mine. We can also have whether it's a number. Now this will need a value, so we'll just name it value. It'll need to be an int. Now we have two options here. When it's this state here, we can either use the number 0 and work it out from that, because that technically is what it is, but since this is meant to match the UI, we'll have this value being null when we don't want to show anything. So here we'll make that nullable. So now we can actually create the composable for the tile. So we'll add a new file here. We'll keep everything within a file named Minesweeper board. So here we can create the composable, and we'll name it tile. And this will need a tile state passed through. So we'll add a preview to start with. We'll just say tiles preview. And within here, we'll want to view every possible tile state just so we can see that everything looks correct. So we'll start by creating a private function down here. We'll just name it get all possible tile states. And this will return a set of tile states. You can say tile state dot hidden with flagged as false. Do the same for flagged as true. And we'll move on to the revealed states. The first one will be reveal.mine, and we want reveal.number, and the value is null. Then we'll want to see every single number, so that's 1 through 8 for Minesweeper. So now that we have those, we can say file states equal get all possible tile states, and we'll show this with a flow row, and this will be experimental, so we'll opt in. And in here we can say for each state we will draw the tile. For now we'll just give it a size of 32. So at the moment this isn't displaying anything, but we can fix that. We'll just create a box. In here we'll align the content to the center. You can use content alignment for that. And we'll use the modifier that's passed through. Now we'll add a background to this. For now we'll just use color.gray, but we'll change this soon. And within here we can say when state and allow it to fill all of our options available. So we'll start with hidden. If we look back at the design for hidden, so we're ignoring the border for now. This is something we're going to draw later in the episode. All we care about is what's shown in the center. So in this case it can only be the flag or nothing at all. So if we go back to the code, all we need to do here is check if it's state.flagged, and then we can show the flag. Otherwise we don't need to draw anything else. So within here we can say icon, and we're going to use one of the icons provided but from the extension library. So we first need to go, we'll add this into the UI core module. We go to the build.gradle file for that. We can add it here, so it'll be compose.material icons extended. So we'll sync that. Wait for that to sync, and now we should be able to access icons.filled.flag. We don't need a content description for this. And we'll give it a max size, although we don't want it to take the full size. This is just within a portion of the square, so we'll just eyeball this and say 0.6 for the fraction, but we can change this later if it doesn't look right. Now we'll change these to-dos into empty code blocks just so it can run, but we should be able to see the preview now. So we'll run this, we'll say desktop, and as you can see this is the tile here. This just looks like one long rectangle, but if we'll temporarily add some space in between each item, we should see that these are now each individual tile. So it's not drawn anything for either of those two yet, so we can fix that. So for our mine tile, we're going to use this mine resource. So this is from pictogrammers.com. They're a nice source of icons that are free to use. So from here we can press this and download SVG. I've already downloaded it. So we go back to here, we need to add this into our module. So this needs to be at the same level as this Kotlin folder, so play/source/common main. Within here we can say compose resources. Now one thing we need to do is go to the build.gradle file for this module, and within the Android block we can say compose.resources, and we need a public res class, and we'll say generate res class always, and sync that. Now we need to actually add the file into this folder. It doesn't seem to be that simple in Fleet. I'm just going to copy the XML from this file because this is just currently in my downloads folder. I'll just copy that and create a file in here, mine.xml. So that should appear now. So we can say icon. We'll use Painter for this, and Painter resource, and we should have access to this res class now. So res.drawable. This should work very similarly to how you do it in Android with the resources files. Sorry, this should be inside a drawable folder like you do in Android. So I'll move that into there. So compose resources / drawable. And now we can access mine. So similarly to the flag, we'll say content description equals null, and we'll say modifier is fill max size, and we'll add a fraction to that. So we let the preview generate. We can now see the mine. So it's starting to look a bit like Minesweeper now. And the last thing we need is the number. So the same as what we did for the flag, where we only need to show something if it was flagged. We can do the same for the number. So we can say state.value, and if this number exists, we can then draw it. So this is just going will just be number.toString, and the modifier we'll say fill max size, but we'll wrap the content height because we want to center align the text vertically. Let's say alignment dot center vertically, and we need to do the same horizontally. We can do that with text align. And all the numbers are now centered. So now we'll add the colors to the app. So we'll start by opening the design, and you can see we've added all of the possible colors that we're going to use throughout the app. So I'm just going to add these into a data class now. So we'll just do this within the Minesweeper board file. We'll add this as a color scheme. So this should be an immutable data class, and we'll call it Minesweeper board color scheme. Now we're just going to add each of the colors that we can see within the design here. Just to quickly run through what each of them do. The background is the background color of each tile. We have border light and border dark. This matches the border on these tiles, so that's the border light, and this bottom right is the border dark, and on these tiles it's just all border dark around the whole side of it. So I'll just quickly add those into this file now. I'll speed this up. And the last one to mention, timer text. This is the text that will show outside of the board. That'll just show the remaining number of mines left and the timer that counts up while you're playing. We covered composition locals in the previous episode, so if you haven't watched that, I'd recommend watching that before continuing. But here we're going to add a composition local for this color scheme. So we'll say we'll keep this internal val local Minesweeper board color scheme. We'll say composition local of, and we'll fill out the Minesweeper board color scheme, and we'll do this using these hex values shown on screen here. I'll speed this up. So now we can actually use this color scheme. So if we go back to where we're declaring our tile composable, inside the hidden tile state where we're using the flag, we can set a tint. We can say local Minesweeper board color scheme dot current dot flag, and similarly we can do that for the mine. And lastly, we can do that for the color. This is a little bit more complicated. So we can say we'll use a when statement with the number as the subject of this statement. So we can say when it's 1, it will be 1, and we'll do this for every number. And we'll add an else, and for this we'll just simply say color.black. Now we can pass this color through to this text object. Color equals color. And we can see the colors applied now. The only thing left to change is this color.gray we originally set for the background. We'll change this to be background. Okay, they're starting to look more like Minesweeper tiles now. So now we'll look at actually adding the borders. So we'll start with this one here, as this is the most simple. So after applying the background, for this we can simply say border, and the width. Well, this is something we'll pass through to the tile. So we'll call this revealed border width, and we'll also pass through, let's just import that, and we'll also pass through the hidden border width. So the revealed border width is how thick this border is, and the hidden border width is how thick this one will be. So here we can say revealed border width, and the color needs to come from our color scheme, and this will be border dark. And the build has failed because we need to pass this through. So for now we'll just say revealed border width is 2, and we'll say hidden border width is 4. Okay, so now that that's built, it's starting to look a bit better now. What I'll do is remove this horizontal arrangement so it looks a bit more like a Minesweeper board. And next we need to add the border for the other type of tile. So to start, instead of just calling border here directly, we'll say run, because we need to check the tile state to see which type we need to use. So here we'll say if state is tile state.revealed, then we can use this border. Otherwise we need to use something else. So this one is a bit more complex. So what we'll do is we're going to create an extension to the modifier. So we'll just create that here as a private function, and we'll call it, we'll just name it hidden tile. And this needs border thickness. And that should be all it needs. And what we're going to use here is draw with content. So this just allows us to draw over the composable or behind it, depends when we actually call draw content. In this case, we're going to call this first, and then we're going to draw over everything. So we'll start by we'll just add it up here so we can see the preview as we go. So this border thickness should come from hidden border width. And first thing we need to do is get the pixel value of this thickness. So we'll say thickness pixels is equal to border thickness dot to pixels. And then we need our light color. You can get that from the color scheme. Our dark color. And this will need to be composable because we're accessing that. Next, we'll create a variable for the width and height. We can get that with size.width and size.height. Now this is where we're going to actually draw the border. So we'll start with the top and the left. If we go back to the design and click into this, we can see the points that we need to create. So all of these white circles, that's the path that we're going to draw. So I'll type the code for this and I'll show on screen which point we're drawn. But hopefully you should be able to work it out through the code. So we'll use draw path and we'll create a path. So for this one, we'll move to the very top left and then we'll draw a line down to the bottom. Then we need to move inwards widthways the size of the border thickness, and we need to move diagonally up and to the right, so we need to move upwards in the y direction. So for that we can say height minus the thickness. Then we're still in the same y, still in the same x, but we need to move up to just the border thickness. And then we'll go to the right hand side of the tile, but in of the thickness. This is something that I'm struggling to explain while I'm typing this, so I'm hoping the diagram will be good enough. But this should be everything we need for this white section here. So we'll give it a color. And hopefully we should see. Okay, that's failed. Okay, because this is composable, what we'll do is we'll just pass in the border light color, and we'll also pass in the border dark. We'll just name that light color and dark color. So we come back up to where hidden tile is used. Pass those in. I just had to restart Fleet to get the preview working, but as you can see, the white section is drawn first. To show this a bit better, we'll increase the size of these. We'll say hidden, we'll set that to 12. Yeah, as you can see, it's looking a lot better. So now we just need to draw the dark, which is the right and the bottom. So similarly, we're going to draw a path. So this is right and bottom. So for this one, we'll start 0 on the x-axis, but we'll start at the very bottom, and we're going to go around clockwise. It's hard to see because of this error, annoyingly, but we'll go around clockwise and back to the start. So we want a line to, this will be the thickness. We'll want height minus the thickness for the Y. Then we'll want the width minus the thickness. Then the height minus the thickness. And we'll want the width minus the thickness again, but this time just at the thickness for the Y. And lastly, the very bottom right, we'll want width and height. Now for this, we'll pass the dark color. Let that build. And that's essentially everything we need for the tiles. So I'm just going to change the preview back to what it was, which was 32 and 4. And they're starting to look like Minesweeper tiles. So the next step is we need to create the board itself. So we'll start by creating a composable. I'll name it Minesweeper board. And this needs the tile states passing through. Now this is going to be a list of tile states. So we're going to do this x-axis first and then y. So for example, the first list, think of it as each column. I'll explain it a bit better once we have a preview showing the board. That should be everything we need passed through. So to start with, we'll ensure that it's not empty and tile states actually exist. And then we can get the board height. So we'll do this within remember. We'll say tile states dot first dot size. So this is assuming that each list within this outer list are the same size. It's could be argued that this isn't the best way of doing it, but for our use case it'll work fine. We can check the board width just by getting tile states dot size. Okay, so for this we're going to need a box with constraints because we're going to need to know the size of it. And this is where we'll pass through our modifier. And within here, we're going to get our required ratio. which is the board width over the board height, and we'll want this to be converted to a float. And we'll get the current ratio. Current ratio, which will be the max width over the max height. So what this is checking is the ratio of the screen available. So in this preview, this whole white section, the required ratio is say if we had 10 by 10 for our tiles, this required ratio will be 1. So what we're working out here is how to fit that best within the screen. So now we'll work out our tile length. So first we need to know whether the required ratio is greater or less than the current ratio. If it's greater, this should now fill the width of the screen. So we can work that out by saying max width over the board width. Otherwise, it should fill the height. We can say max height over board height. So now we have the tile length in density pixels. We can now use that to size our tiles. Add a row. And make sure everything's centered. Then here, this is where we'll calculate the width and height. So for the width, we can say the tile length that we've just previously calculated times by the board width. And we need the height. Now within here, we can iterate through our tile states. So we'll say for x in tile states.indices, we need a column. And then we can say for y in tile states x dot indices. One thing we need to do with this column is center this. And this should fill the max height, and we can use weight just so that each of these columns within the row are going to be spaced evenly in the space available. So now in here we can get the tile state. And we'll draw the tile. So we'll need our revealed border width and our hidden border width. And what we'll do is we'll calculate these based on the size of the tile so that we can scale our board as much as we want, and it'll always look correct. So for the revealed border width, we'll say the tile length divided by 8. And for the hidden, we'll say tile length divided by 32. So the revealed, just as a reminder, is this one, which is a lot smaller than what we see for hidden. We'll pass that in, and then for the modifier, we can say fill max width, because this is inside the column, and the weight should be 1f, so we're just evenly spacing it within that column. Now we'll add a preview for the board. We'll just name it Minesweeper board preview. And now we'll use our function we created earlier for getting all possible tile states. And we'll build our list of tile states from this. So this is going to be a list of tile states. Let's say build list. Now we'll repeat 10 times for the width of the board. And we'll add our inner list. And within this we'll do the same again. We'll repeat 10 times, so we'll be previewing a 10 by 10 board. And within here we can add, we'll just say all possible tile states dot random. We'll run this preview. And we see nothing because I'm not calling Minesweeper board. So here we'll pass the tile states. Our modifier we'll just say fill max size. I've done these the wrong way around. This revealed, yes, the revealed is the smaller of the two borders. So here we'll say 32 and this one we'll say 8. And that's starting to look like Minesweeper. The only thing left to do is we need to scale the size of the text, because at the moment this is just a constant size. So we'll pass through a text style into Minesweeper board. This will just default just to text style. Now we need to adjust it based on the size of the tiles. So we need to use this tile length. And here we can say, we'll call it size adjusted text style. And we'll create a copy of text style and change the font size based on the tile length. For this we can say tile length.value.sp to get a rough size for the font. And we don't want it to match the full tile length, so we'll decrease it a little bit just by using a multiplier. So now if we pass, well, we need to add this into tile as well. We'll say text style equals size adjusted text style. Now if we jump through to tile, we'll do the same here. We'll add a text style parameter with a default value and pass that through to this text composable. As you can see, the numbers are taking up almost the full size of the tile now. I'll make it a little bit smaller, but it looks roughly right to me. So the last thing we'll do is just go back to the preview and we'll just test a few different sizes. So to start with, we'll just put a fraction in here and just see what it looks like with half the size. That still looks okay to me. I'll make it a bit smaller. Yeah, it's hard to see, but everything looks to be scaling correctly. So we'll get rid of that. Now we'll set a portrait version of Expert Minesweeper, so 16 by 30. As you can see, this is filling the screen fine. We'll try increasing this a bit more. And this looks fine to me. One last thing we'll do is just center the board within the available space. So we can do that in the box with constraints. We'll say content alignment equals alignment.center. And now that should be centered. We'll just check it works if the width is greater than the height as well. We'll say 16 by 10. thinking. And yeah, as you can see, that's centered as well. So that should be everything for this episode. We haven't actually added the board into the app itself, but everything's set up UI wise, so it's ready for when we need it. In the next episode, we'll look at using data store within Compose multi-platform, and with that we'll set user preferences and settings for the app. Thanks for watching.